Hello, today we have 934 shortest bridge, and you're given an binary matrix grid when one represents land and zero represents water. The island is, okay, we know what this island is. There are exactly two islands in the grid. Okay, humor change to connect the two islands from one island to another. Return the smallest number of zeros they can flip to two islands here. So we have grid of islands. There are exactly two islands in the grid. Okay, so it looks like this problem can be solved if we split the entire thing. So we need first find island, and we use DFS obviously to find it. Then we use BFS to find shortest path, and we return shortest path. Right? So this is like the whole thing, and so we create DFS first. DFS on the matrix, and we receive row column, right? And we can find, and we can define n as length of grid. So we will use it, and in DFS we will check if we have to define visited, because otherwise we will go into as hash map default dictionary, and no, just a hash map. And then if RC in visited, not RC in visited, or we have to check in if RC inbound, so R not visited, then and R is more or equal 0 and less than n, and C is the same. And the grid R and C equal 1, then we call DFS. Oh, we have to add visited. We append. It's kind of like a set, right? So we do set visited add, and we add to visited. We add R and C. Row column, and then for E in, we have, let's define directions. Here's equal, it's like a list of 0, 1, 0, 1, 0, 0, 0 -1 and -1 0, and we have a direction R and direction column. In directions, we call DFS for R plus DR and C plus DC. So in result of working this, we were gonna have first island. No, we have to call it for E in grid, and for R in range of n. So this is row, this is column. We call DFS row column. Right, so in this case, what will we found? We will have all, we're gonna have all islands in there, right? But we need to have, so we call it, and but we cannot call it on anything. We have to call it if grid R and C equals 1, then only one we call it. And then in this case, so here we should call BFS, return BFS of whatever we're going to have visited. So this is step 3. So this is step 1. We will find first island by here. And this is step 2. We will return BFS. So we have to define the BFS, and BFS is gonna be, we will define like result, and the result is equal 0. And then what we need to create Q from the Q from the visited, and then while Q for the same in directions we have, and in here if grid equals 0, right? Oh, but we have to calculate the same. We have to make sure it's practically the same, right? Yeah, it's pretty much the same. If not RC in visited RC and grid is equal 1, but not 1 if grid is equal 0, so in this case we just return rs, because in this case we have, otherwise we add rs plus equal 1. However, we have to pop from the queue, so we do for e in queue, right? What we're going to do, we're going to pop RNC from queue pop left. Now, so there is something wrong with here. We cannot so that means we reached, but how about if we are still traveling on land? So if in visited, then we continue because we are traveling on land. And or if we are outside of the range, so if we are outside the range, we continue to or if we visit it. Then if grid is, and we are not in visit it, it's kind of like implies this, right? Otherwise, if grid is zeros, means we still on water. So we have to add this water to append, and we have to add not quite. So let's call it running or like exploring row. Let's call it exploration row and exploration column, right? Which is a row plus er and column plus tc. And here we have EREC, EREC, or here we also have a or, and then we check EREC, and here we add in EREC2. And if we add it, we have to add it to visited up. Add yeah, the EREC2, the same. Okay, and as a result, at the end, we return res. Okay, so this is basic BFS look like. Int is not, yeah, it's range. But if should I do n minus 1 in this case? Still, list is out of range. Okay, let's do this. Yeah, I or not. Oh, it's too sexy. Okay. Oh, because I have to verify ER here and EC, but not. Okay, visited type unhashable type list. But visited is set. You mean if I did the queue visited, is it become a queue? Hmm. Visited queue while queue visited and it's still set, right? If I the queue, it become a queue. But I am adding it to queue. Excuse me. Okay, let's not do it. It's probably yeah. We will go. We'll have a back and forth. We need this visited or not. Yep, memory limit exceeded because if we go back and forth, we have to keep visited in visited EREC. Maybe we should. I don't know why I can add it to queue, but I cannot add it here. Oh wow. Yep. N square. Yeah, it's like fair enough. N square for that because we're doing two for loops. And yeah, that will be it. So it's very good task to practice both BFS and DFS, and you can see that BFS is much more complex and DFS is much more simple. But it's kudos to the author who made a task with two of them in it, and yeah, it's a good chance to practice BFS in the grid in the matrix. Um, that's it. Thank you for watching.